Okay, this is our last tutorial, which is how to make the leg to be able to stretch when I drag the IK down. Okay, now it's actually super similar to the ones we did on the torso, which we need to subdivide the current length by the original length and then get the scale of the joints. Alright, so the original length of the leg will be actually represented by this curve we created to place the joints, but I need to go to vertex mode and delete those two because they belongs to the foot. And right now this curve, its length is exactly the length of the leg. So let's try to get it. Let's go to window, node editor. Let me clear this and then let me go change the tab to back. Up. Left leg stretch. Okay. Let me drag this curve in and then select the shape node. I need to measure the length, and it's very simple to do. All I have to create is a curve info mode. See, curve info node. So curve info, and curve info left, back, left, stretch. Oh, let's call this original length. Okay. Now we need to drag the space to input curve to get the length. Okay. And then the arc length here will represent the original length. Now you have to be really careful about your unit here, which I will show you why later on, but for now, I'm making sure that you know what the working unit it is. If it's centimeter, like what I have here, it will work just fine, but some of you guys, maybe most of you guys, are using a foot instead, and that may need some tweaking later on, but just check that here first. Okay. Anyway, now I have the arc length, which represent the original length. So the current length will be determined by the distance from the hip joint to the IK controller. To measure that, I need a measure node. Before I create that, I need to select the IK controller and go to display, transform display and rotation pivot, so I know the pivot is here. Okay. Now let's go create measure tools and distance 2. Holding down V button to snap the first locator at the beginning of the leg, and then holding down V again, click on the pivot of the foot. Actually, we just need to snap it here, so maybe we don't need to see the pivot, but anyways. So now the length between the hip all the way to the foot will be measured, and this length will be our current length. Okay. So let's rename this one current length. Okay, I don't need to see all those nodes here, so let me go and get rid of those, including that one and that one. Okay. Now this is the current length. This is the current length, and this is the original length. All I have to do is use multiply divide to calculate the scale factor of my bending joints. So multiply divide back left leg stretch amount. Okay, and then the calculation will be subdivide. So operation to subdivide, and then or divide the distance will be input 1, and then the arc length will be input 2. Okay. And then the output will be the scale X. But there's one thing you have to be really careful about. Let me remember that when we were doing this, it's a direct connection here, which is seems really nice. But if your working units is something called the foot or inch, okay, and let me reconnect those. You see the arc length actually created a unit conversion here. And this unit conversion will convert foot to centimeters, so you are getting some weird different results. Oh, sorry. It converts centimeter from arc length to foot. So 5 foot is here, and that's 151 centimeters. So they're different units. So the number here is clearly wrong. If you have that here, you want to go select it and then change the conversion factor to 1. That means we're not changing the output here. So we're getting the correct value with the same unit between input 1 and input 2. Okay. This is something to be really careful about. This is really kind of weird why Maya does the unit conversion here but not doing it when we were dragging the distance. I think the safest way to do this is that you keep your unit as centimeters, because that's just how Maya run natively, and I think it's also a very good value to use for game engine like Unreal Engine or Unity. Foot is more, I think it's more convenient for architectural visualization or things like that. So, and it's really hard to calculate foot because it's not by 10 somehow, but centimeter is just, you know, something I feel more comfortable with. So let me go back to centimeters and delete that unit conversion. Let me just reconnect. You see, Maya never create that unit conversion anymore because that's the value Maya use natively. Okay, cool. Now let me go select the locator 2, and then the locator 2 will follow the IK. So let's select locator 2 and holding down shift, select the IK controller and press the P button. That way when I drag the IK, I'm constantly measuring the distance. The other locator will be parented underneath the joint. So let me go and show the joint. Let me close that. The joint will be back, left leg, joint group. I have all those joints. Let me go and select the others and have them only giving me the binding joints because that's the one that actually matters. So let's select the locator and parent it underneath the joint. Okay, cool. Great. Let's go back to the node editor. And then let's go grab all the binding joints from the beginning to the ankle, which are those 4. 1, 2, 3, 4. Yeah, that's them. And drag them in and press 3 to open it. Now all I have to do is use the output X to connect to scale X of those joints. So output X to scale X. Okay. That way when I start dragging the leg, it will become longer and keep just becoming longer and longer and longer when I drag it longer. But there's a little problem here, which is the leg actually becomes smaller when I connect those. The reason is pretty obvious. The current length we're measuring using the distance to is actually the direct distance from the hip to the IK controller, and it is supposed to be smaller than the length of the curve we measured because apparently the curve goes is not a straight line. It goes through those turns, so it's longer. Actually, because of that, we need to make the scaling happen when the leg is actually becomes straight. And when the leg actually becomes straight, when we drag the IK down, that's when this distance we're measuring is the current length. And that's when I really want it to be stretched anyways. So to do so, I need to have a condition node, C1 condition. Okay, condition node, and let's name it back leg. Okay. Now I have two terms, first term and second term. I need to compare the distance with the arc length. So first term will be distance, second term will be the arc length. I'm going to measure it, compare those two and see which one is bigger. If the first term is greater than the second term, and that's when I really want to stretch it, because that's when the leg becomes all straight and even longer, and that's when this distance measurement is longer than the curve length, which is the length of the entire leg. Okay, and that's when I want to stretch it. So instead of using this output X directly to go there, I then need to go connect the output X to color if true. So only when this is bigger, the first term, which is the current length, is bigger than the original length, which is this one, second term, the length of the curve. When the distance is bigger than that, that's when the leg becomes straight, and that's when I want to use this value instead of 1. Okay, so color if false is 1, and then we use the out color to control the scale X. Oh, sorry, out color R to control the scale X. Okay, that way when you zero out the translation, you will see now the leg stays as the bending post, because in this case this length we're measuring is not longer than the arc length, so it's exporting color if true here. Okay, so the color R, out color R in this condition is color if false, because the condition here is false, meaning that first term is not greater than second term here, and this one will be used as color output color R, and this one is never being used to export. Anyways, so that's the basic idea of the IK stretching. Now let's do the volume maintain. Volume maintain is something we already know, so let me just do that real quick here. What I need to do is create two multiply divide node. Let's call this one stretch amounts square root. Okay. Now this one, I'm just gonna call it a volume maintain. Okay, so the out color here goes to input 1. This multiply divide will be a power, and input 2 will be 0.5. That gives me the square root of input 1, and then this output goes to the input 2x of the second multiply divide. It's gonna be a divide calculation. The input 1 will be 1, and then the output goes to scale y and z. Okay, let's just keep going because they're sharing the same value anyways, so I can just connect them like this. Alright, now if I start dragging the leg, you will see that it becomes thinner, and that's what happens when we do this. Okay, now sometimes I want to control, like, do I really want to have that volume maintain, because sometimes I think it's up to the animator to decide, you know, how much the stretching is. Shape-wise, we want to have the flexibility to control it. So that's why we need a new attribute on the controller to define do we want to have the volume maintained or not, or how much. So let's call this volume maintain. Minimum is 0, maximum is 1, and add, and then let's drag it in. Okay, let's get rid of that. And then I just need to have a blend color here, so let me create a blend color. Let's call this blend color back left leg volume maintain. Okay, and then the volume maintain will be controlling the blender. Okay, and then the output X will go, the actual output X, which was connected directly to scale YZ, now goes to the color 1. The color 2 will be 1, and then the output replaces the scale Y and Z. That way we have the ability to control how much do we want the inverse scale to go. Oh, something's wrong. I'm getting 0 here, which it shouldn't be. Let's see. Oh, that should be 1. Type in the wrong field. Alright. Now if I drag it down, it will not maintain the volume unless I drag the maintain volume up to 1 or something in the middle. Okay, so that's volume maintain. Quite simple stuff, and we did that before. So okay. Now that is pretty much the setup of the IK. But when we drag it down, and then drag the slider back to FK, you see FK is also stretching, which is not cool. So I have to fix that. To fix that is also very simple. All I have to do is when we blend back to FK, we want to turn off the scale. So let's just go create another blend color here. This one will be called back left leg volume IKFK blend. The longer the name is, the more descriptive the name is, it's actually the better. So I will always name everything to make them make sense to me, at least in the future. Anyways, so output R, then, oh, sorry. Yeah, so now the stretching IK gives us are those connections. So let's use those connections to populate color 1. Okay, so this goes to color 1 there. And then the output of the volume maintain will go to color 1G and 1B. Okay. And let's change color 2 to all ones. That means we're not changing anything. So now I need to use the IKFK slider, which is this one. Let me get it in. Okay. Now this slider gets to decide are we using IK or FK. Right now we're using IK, in which we have a value 1. So all I have to do is use translate X to control the blender. So when the translation X of this slider is 1 now, I'm in IK mode, which it will output color 1, which is the IK, right? That is what IK does to the scales. And if it's 0 here, which goes back to FK, right? And then it's gonna output the color 2, which is all ones here. So we're not changing anything. Let's drag the output. Oh, let's delete the connection here and drag the output to the scale. Okay. That way, when we switch to IK should be able to stretch it, but when we go back to FK, the stretch gets blend back. Okay, and that's the entire setup of IK, FK, of IK stretching. Okay, so it's actually a fairly simple process. There is very little new stuff here. It's just very simple logics. And that should wrap up all the rigging concept I want to go over this semester. Maybe you're wondering like how you connect everything back together, right? It's actually quite simple. All you have to do is use this joint. I already done this part, so let me do that on the other part. All you have to do is use this joint here, the root joint, to do two constraints. One is on the joint group. Okay, constraint, parent constraint. Another one is on the FK's group, FK controllers group, AC back FK. Okay, constraint, parent. That way the following will happen. Okay, cool. So that should be it. Final clean up the distance dimension. I can name this distance dimension back left leg GRP. Oh, back left leg original lens, current lens actually. And this one can be parented literally underneath anything, so let me just drag it to the back left leg regroup and probably throw it underneath the other element group, and that should be it. Okay, so yeah, that's everything I want to go over this semester. We have learned some basic stuff at the very beginning on the joints, and then we did some exercise with weight painting on the fish and also the other two characters, and then we start a character, and that goes all the way through half of the semester. Okay, and then I give you guys a few work days to work on your own, and then I did some in-class competitions for the ones we already know on the giraffe, and then I finish the other parts that are new to you, and that's the whole structure here. And I think we did a good job on introducing those stuff, and I do believe that you also have learned a lot from this rigging class. The point is that learning rigging is not memorizing a lot of things like how to do this or that. It's more like understanding the alignments, the components you need for different setup, understanding them, and then when you're actually doing your own rig in the future, you may end up using all those different alignment or methods in different ways to achieve certain goal. So I don't want you to think that the thing I teach you right now will be the golden standard or the solution. It's just one of the ways you can go for, and there could be other ways, either or harder or for particular situations. So keep an open mind with rigging. It's more like programming. Everyone have different ways of writing their code, organize their code. Like my way is having all the groups, and then differentiate ACs, joints, and other elements. So let's just make it easier for me to think, but you can definitely arrange things in different ways if you think that's better for you to think about it. So next semester we will go over more interesting stuff like secondary controls, joint-based facial expression, secondary controls in the phase 2, and then other like stretch and squash of the entire body, mechanic rigging, using dynamics, so all those awesome stuff that we can go over. So I hope you're prepared. Rigging is not an easy thing to learn. I know that we are all having big trouble understanding things, and not only you but me constantly find out that sometimes it's really hard to fix the problem you have and ask me. And I get more experienced too because of that. So thanks for I really like you guys asking me questions, because that gives me a very nice, like very simple practice to troubleshoot what's happening. As a rigger, it's not only the ability to rig stuff, but also the ability to come up with new ideas and fix potential problem, troubleshooting, all kinds of stuff. Okay. All right. So I have been having a very, I think, productive, awesome, and exciting year. So I can't wait to see you next semester.